We have a double integral over rectangle. The function is x over 1 plus xy. Imagine you are holding up a piece of paper, so that is represented by x over 1 plus xy, and then on the table, so you're holding this paper over your table, and then on your table, which is the xy plane, the shadow of the function is a rectangle, and then we are only interested in x between 0 and 1, and y is also between 0 and 1, and we want to find this double integral. Okay, so the way to do it is, there are two ways to do it. You can do a dx dy, or you do a dy dx. Let's start with a dx dy. So let me pick a different color to do a dx dy. Let's pick green. So dx dy, so I will start with integral. This should be enough. So what dx dy, right? So we will be doing a dx dy, and then y is from 0 to 1, y is from 0 to 1, x is also from 0 to 1. And then the integrand is x divided by 1 plus xy. 1 plus xy. You know what I'm trying to do a u substitution. So the u substitution is, I am going to let u equals to the denominator 1 plus xy, and then du with respect to x, this is just y, right? 0 plus y dx, and then 1 divided by y du is equals to dx, and then we have to change the x in terms of u. So u when x is equals to 1, which is 1 plus y, and then u when x is equals to 0, which is 1 plus 0, which is equals to 1. And then we also have to change the x in terms of u, so x is actually equals to u minus 1 divided by y. Okay, so we turn to the double integral. We have 0 to 1, and then our this, I will just do a u from 1 to 1 plus y. You know what? Let's write this. U from 1 to u equals to 1 plus y. And then the x is y minus 1, y minus 1, u minus 1 divided by y. That is the x. That is the x, like right over here. That is the x. And then the dy is, the 1 plus xy is what? That is a u, right? So that will be a 1 over u. And then how about the dx? The dx is now 1 over y, 1 over y du, and then you have the y. So that is the dx, and then the dy follows. That is where the dx is. Okay, you got this, and then let's highlight that a little bit. So this one, this is actually the whole thing. Okay, that is from here. 1 plus xy is equals to u. Okay, so that should help you to follow. Can we reduce something? The du, right? So that means the y is a constant. Okay, I can just take the y out for the next integration. So 1 over y squared. And then we have u equals to 1, u equals to 1 plus y. And then the rest will be the u minus 1 over u, right? The u minus 1 over u, u minus 1 over u, and then du dy. You know what? The u minus 1 over u, I would like to rewrite that as a u over u. U minus 1 over u. So that would be a 1 minus. That will be a 1 minus, right? So we have a u minus 1 over u. So that will be a 1 minus 1 over u. Okay, 1 minus 1 over u. Okay, let's do this. 1 minus 1 over u. Okay, because I'm checking my notes to make sure everything is right. The y is taken out. You have a u minus 1. So the u minus 1 is from here. So x is equals to xu minus 1 divided by y. Okay, that is right, because I don't want to make any mistakes right here. So u minus the 1 divided by y. Okay, so u minus 1 over y. Okay, so that is a 1 minus 1 over u du. All right, from 0 to 1, 1 over y square. The integral of 1 is u, and then minus ln absolute value of u. So since y is between 0 and 1, I don't think you will need the absolute value. This is because x and y are both positive, you add a 1 to it, you do not need the absolute value. 1 to 1 plus y, and then this is a du, right? So this is done, and then we have a dy. And then we do a fundamental theorem of calculus from 1 to 0, and then 1 over y square, and then we have 1 plus y minus ln 1 plus y, and then minus 1 minus ln1. ln1 is equals to 0, so there is a parenthesis, so you are actually subtracting 1 only. Okay, I'm going to erase the whole thing and then just change this to subtracting 1 only. And then this is over a dy. All right, okay. We have a multiplication, right? And then we also have a 1 minus 1 that is gone, and then we have from 0 to 1, and then the 1 minus 1 is gone, y over y squared, that will be a 1 over y, and then minus ln 1 plus y. You know what? 1 over y squared, and then we will have a ln 1 plus y, and then a dy. So that brings me to another by parts. That brings me to another by parts. Okay. So we will have an integral 1 over y from 0 to 1, and then minus integral from 0 to 1, 1 over y squared, and then ln 1 plus y dy, and then that brings me to another by parts. So that brings me to another by parts, integration by parts. And then that one, so instead of keep going, I will just give you the final answer. The final answer of this is equals to 2 ln 2 minus 1. That is, I prefer to stop the problem right here. So this one has more steps. So this one has more steps. So instead of doing dx dy, can we do a dy dx? Can we do a dy dx? Let's try. Let's try to do a dy dx using a different color. Okay, so I will be doing from dy dx. So this time we are doing a dy dx, and then the function is x over 1 plus xy. Is that going to be easier? Y equals to 0, y equals to 1, okay? And then x is from 0 to 1. Is that going to be easier? Okay, the first problem that will be doing an integration by parts, right? That will be an integration, not integration by parts, that will be a u-substitution. So u equals to 1 plus xy, and then du equals to just an x, dy, and then we have a 1 over x du equals to dy. And then u when y is equals to 1, u when y is equals to 0. So that is a 1 plus x, this is just a 1. Okay, so we have from 0 to 1, this is u from 1 to 1 plus x. And then, oh, the x we have to do some rewrite. So that one will be x will be, this should be easier. U minus 1 divided by y equals to x. How about that? U minus 1. Or is that really necessary? You know what? That is not necessary. Here is the reason. So the x, I can let the x stays. And then the denominator is just a u. And then watch this. The dy is 1 over x. So I do not need to rewrite the x. So that will be a 1 over x du. And then we get rid of the x. Yup, there we go. And then we have a dx follows, right? 0 to 1. and then the integral of 1 over u is absolute value, ln absolute value. I don't think you will need the absolute value. And then u goes from 1 to 1 plus x. Because x is between 0 and 1, you add 1 to it, that is guaranteed positive. Then it is no need to use the absolute value. Okay, plug in. From 0 to 1, that will be a ln 1 plus x, and then minus ln 1, which is a 0, and then a dx. So we are integrating from 0 to 1, ln 1 plus x, and then a dx. This will be another integration by parts. Integration by parts. So for integration by parts, you always need to let the u equals to ln and then take the derivative of that, because we assume that we do not know the integral of ln. So and then du is equals to 1 over 1 plus x. The derivative of the inside 1 plus x is 1, and then a dx. And then the dv is the rest, which is 1 times dx, and then v is the integral of that, which is equals to x. And then you have uv minus the integral of v du. uv minus the integral of v du. So uv, that is equals to x times ln 1 plus x, and then x goes from 0 to 1 minus the integral of v du. The v is x, the du is 1 over 1 plus x, and then a dx. Ooh, that will be another u substitution. Okay, let's see. This will be a ln, right? ln 1 plus 1 is a 2 minus a 0. Minus a 0. 0 times ln 1, which is just all 0. So this will be another u substitution. So we let u equals to 1 plus x, du equals to dx. How about u of 1? 2. U when x is equals to 0, 1. And then this we have to do a rewrite. So we have to do a rewrite that x is equals to u minus 1. So this will be u from 1 to 2, 1 to 2. And then we will have the x is a u minus 1. And this will, and then the other one, 1 plus x will be just a 1 over u. 1 over u du. And then this we just have to keep going. So ln 2, and then minus u minus 1. Okay, so that will be from 1 to 2, 1 minus 1 over u du. All right, and then we have ln 2 minus, this will be a u minus ln u, and then u goes from 1 to 2. And then we have ln 2 minus, plug in a 2, 2 minus ln 2, and then plug in a 1, minus 1 minus ln 1. What do we have? We have ln 2 minus 2 plus ln 2, and then minus 1 minus minus is a plus 1. Is a plus 1. So this one we have a 2, ln 2, 2 copies of that. Negative 2 plus 1 is a negative 1. So which is the answer? So that is the same as, this is a dy dx, which is the same as the one using dx dy. So this is using dx dy. I skip the integration by parts because of you can try. It isn't that hard to do. That is a 2 ln 2 minus 1, and then this is a 2 ln 2 minus 1. So this is from the dy dx integral, right? So that is from the dy dx integral. So the conclusion is, it doesn't matter which one you do, the dy dx or dx dy, you will get to the same answer. Sometimes when you do the dy dx, it is easier. Sometimes when you do the dx dy, it is easier. But if you do the other way around, you might have to do integration by parts, the u substitution a few times to get to the final answer. Alright, so that is the end of this video. If you like the way I explain double integral over rectangles, thumbs up. Subscribe to my channel for more contents like this, and I will meet you all in the next lesson. Signing out.